Welcome to Zoology Zone. Today topic is Introduction to Nanotechnology. What exactly is nanotechnology? Nano word is coming from the Greek word that means dwarf. Nanotechnology is it involves all of the following things like research and technology development at atomic and molecular, macromolecular or molecular levels in the length scale of 1 to 100 nanometer range, creating and using structures and devices, systems, and have novel properties and functions because of their small and intermediate size, ability to control or manipulate on the atomic scale. In the natural worlds, all the biomolecules, many of the biomolecules basically are of nano sizes. So nanotechnology is not new to human beings. It is already exists there, but we are came to across in few years ago, like the size spectrum of nano environmental particles. For example, water is 0.2 nanometer, hemoglobin is 7 nanometer, DNA is like 1 nanometer, viruses in the range of 10 to 100 nanometers, microbial cell is like more than 100 nanometers, proteins, nucleotides, all are in the range of 1 to 10 or 20 nanometers. So what are the nanostructures and what are the nanomaterials? Nanostructures are the sizes, and the nanomaterials are the material which are synthesized by manipulation into a nano size. A bulk material has a different properties, while we creating a nanomaterial or nano size of that bulk material, all the properties has been entirely changed, like optical property, electrical property, magnetic properties. All the properties have entirely changed when we create a nanomaterial from a bulk material. There are many materials which has been exploited or manipulated for this nanostructures. The nanostructures like clusters, nanocrystals, quantum dots. These are in the radius of 1 to 10 nanometer, insulators, semiconductors, metals, magnetic materials. These are the materials like semiconductors, silicon, metals like gold. These can be manipulated. What exactly nanomaterial doing? Nanomaterial means something which has large surface area to a within a small volume. So it has increased the surface area of the volume. Other nanoparticles, ceramic oxides, 1 to 100, nanowires, diameter 1 to 100 nanometer, metal, semiconductors, sulfides, nitrides, nanotubes like carbon nanotubes, nanowires like silicon nanowires, fluorines. These are some of these sizes and the structures of the nanomaterial which are now extensively used nowadays in different, like in healthcares and other part of the science. For example, how can nanomaterials be unique properties? For example, catalytic property, better catalytic efficiency through higher surface area to volume. As we create a bulk material to nanomaterial, convert, it has good catalytic efficiency. Electrical and efficiency is also increased, magnetic is increased, mechanically it is hardness and toughness is also increased, optical characteristics also enhanced. For example, bulk silicon is not optical, whereas the quantum dots and the porous silicon is optical. Spherical, increased selectivity of hollow spheres during drug transportation and controlled release. This is good for target drug delivery. It is very helpful. Biological, increased permeability through biological barriers. Some of these nanomaterials can be used at target drug delivery. These are used to be as nanomedicine, so that the size is so small they can across the cell membrane of or membrane of a target or organ. Characterizing nanomaterials, there are so many ways to characterize, like the origin, natural, unidirectional release, dispersion, shape, structure, surface modification, aggregation stage, and chemical composition. Chemical composition is like for to create from like semiconductors. If we are creating nano quantum dots or nano wires, we deposit some type of metals like silver or something, so that it can be synthesized or manipulated. Surface modification, the surface chemistry of the nanomaterial. When it is created from the bulk material, the surface chemistry is entirely changed, as it is if we want to use in biosensors or drugs delivery. So we have to be bind these nanomaterials to our biological system. So there must be some sort of bonding, a covalent bonding, so that accordingly we'll modify the surface, like from hydrosilation or through silation. These are the few examples, so we can modify the surface of these nanomaterials. Applications of nanomaterials: automotive industries, lightweight construction, painting, fillers, coat, catalyst, tires, sensors, coating, gas sensors, chemical fillers, paint system, coating systems, nanocomposites, impregnation of papers, switchable adhesives, magnetic fluids, engineering, wear protection for tools, machines, anti-blocking coatings, lubricants. There's many for electronic industry. Basically, I'm very much towards the medicine, like drug delivery system, active agents, contrast system, medical. These are also used as the fillers, because these are inert, they are not harmful. So when we inject these nanorobotics or nanomedicines, so they have optical properties, so we can use like photoluminescence in case of silicon. So we can copy the path of that route through which it is passing through in the body. Application of nanotechnologies in textiles, fabrics, energy, cosmetics, sports, household, so many things. Now it becomes a revolution to our life. Nanotechnology plays a vital role in our day-to-day life. Now becomes a part of our daily lifestyle. Thank you.